Hello calculus students, here we are with ellipses and implicit differentiation. The review stuff is writing equations of ellipses in standard form and graphing them. You did that in pre-calc and algebra 2. But now we're going to use our knowledge of implicit differentiation from calculus to find the slope of the tangent line at an ellipse. Here's an ellipse defined as a set of points whose sum of the distances between two fixed points is constant. So d1 plus d2 here, that remains constant. And we have vertices along the major axis, and here's the minor axis with a center. And you can draw these with ellipses with a pencil and string. And also, you might have some fun with, let's take a little pause here, do some work with GeoGebra. Here we are in GeoGebra, and you can look it up under this little symbol right to the right of the circle called ellipses. And let's make an ellipse. And basically you select two foci and a point on the ellipse. So if I make my two foci like here, and come up with a point out here, there's your ellipse. Notice how it's stretched kind of strangely here. Let's start moving some of these things around. See how the foci determine the direction of the ellipse. There's a vertical ellipse, because the foci are lined up vertically. Here's a horizontal ellipse, because the foci are lined up horizontally. And now we can change the size of the ellipse by stretching this point out. And so the sum of the focal radii stays constant. And so I just want to illustrate this idea that the sum of the focal radii is constant. So we take a general point on the ellipse and look at these two distances. Let's make some segments. These are called focal radii. And there we have them adding up to those two. Now if we add up A plus B, we get 7.32. And notice A and B change now as I move D around, but their sum stays constant. In fact, the sum of the focal radii is equal to 2A. And why is it 2A? Remember, A was the major axis, so I'm going to actually draw a line through the two foci. See where it crosses, so we need points of intersection here. Here we go. Intersect the two objects of this line and the ellipse. Now let's find this distance from E to F. Line segment from E to F. And notice that's also 7.32. And notice this stays true even if I make the ellipse bigger or smaller. Hang on. Grab C here. What's our point? Now I've got a smaller ellipse. A and B shrunk. Notice that when I move D around, the sum of the focal radii is 4.43, is still the same. And this major axis is also equal to 4.43. Okay, just a little bit, and you can do some exploring there with ellipses. Now let's go back to our lesson, and that is here's some of the key points you should be looking at when you graph an ellipse. The center is going to be at HK. A is the major radius, and B is the minor radius. And A squared equals B squared plus C squared. It's a little twisted from the Pythagorean theorem, and that's because of the square root of B squared plus C squared out here. Because basically, 2A is the length. And so here, let me do a quick proof here. This is given as A, but you also get A over here. This is A and this is A. Because remember we said the sum of the focal radii equals 2A. And that's equal to the overall length of the ellipse too. And A is the major radius, 2A is the major diameter. And we get diameter this way too. And so A equals 2A equals 2 squared B squared plus C squared, so that's where this formula comes from. Here's the standard equation of the ellipse, and this is available for you on the Handy Forms page. it does a summary of all the ellipses and all the conic sections. And HK is the center, so that's the trick in doing these problems, is finding the standard equation ellipse. Here's an example of actually working through a problem where you're given the information about ellipse, the foci at 0, 1, and 4, 1, and a major axis of length 6. So that means 2a equals 6. And the foci are 4 apart, so 2c equals 4, so c equals 2. And so that's how you can come up with b as well. Now, sketching an ellipse. Let's try sketching this ellipse. X squared plus 4y squared plus 6x minus 8y plus 9 equals 0. What you have to do is separate the variables first. Put all the x's together and the y's together, 4y squared minus 8y, and you're just going to move this 9 to the negative 9 to the other side. And then you have to complete the square in both these variables. So x squared plus 6x plus 9, so I add a 9 to both sides. That'll make x plus 3 quantity squared. But here, don't complete the square until first factor out the 4, meaning 4 times y squared minus 2y plus blank. And then realize that to complete this square, we complete it with a 1, but it's in a group that's being multiplied by 4, so we have to add a 4 to both sides. So you get x plus 3 squared plus 4 times y minus 1 squared equals 4. And we're almost in the standard form. To get in the standard form, we have to divide both sides here by 4. Now it matches this standard form. And so remember that this is under a squared. So the bigger these two numbers underneath is a squared. So a squared equals 4, so a equals 2. And b squared equals 1, so b equals 1. So we're going to go 2 each way in the x direction from our vertex at negative 3, 1. Go 2 to the right, 2 to the left, that gives you those vertices. Actually, I meant from the center. The center is at negative 3, 1. That's one thing you have to watch out for now. When we talk about ellipses and hyperbolas, HK is not the vertex anymore, it is the center. Parabolas don't really have a center, they just have one vertex. Ellipses and hyperbolas have 2 vertices. Here's b equals 1, so we went 1 each way in the y direction. And that's your basic shape of the ellipse. You can fine-tune it by locating the foci and so forth, but that's going to be good enough for what we're doing now. And here's how you could solve it and get into your calculator if you can solve it for y and graph them that way. Now, finding the slope of a graph implicitly, determine the slope of the tangent line to the graph of 9x squared plus y squared equals 25 at the point negative 1, 4. And see the figure. So we know what to expect. We expect a steep positive slope. But now we can get there quickly with calculus. So we go ahead and start taking the derivative of both sides with respect to x of 9x squared plus y squared equals the derivative with respect to x of 25. So you get 18x plus 2y dy dx equals 0. So 2y dy dx equals negative 18x, or dy dx equals negative 18x over 2y, or negative 9x over y. So now to find it at the point negative 1, 4, we take dy dx equal to negative 9 times x, which is negative 1, over y, which is 4, and you get 9/4, or 2.25. And that does look like a slope of about 2.25 there at negative 1, 4. Okay? There you have it. Flange out.